All right, so we just wrapped up chapter 11 where we were looking at perimeters and areas. When we talked about perimeters and areas in chapter 11, we were talking about flat surfaces. Okay, so squares and circles and triangles that were flat or two-dimensional. In chapter 12, we're going to take this into three-dimensional figures. We're not going to talk about perimeters anymore because we don't have a perimeter of a completely solid figure. But the two things we're going to be concerned about are still area. We're going to talk about what's called the lateral area, which is the area of the sides of the figure, not the top and bottom, but just around the sides. Or the total area or surface area, which is the entire area of all surfaces, all the sides, the lateral, and also the top and the bottom. When we talk about the surface area of a figure, what we're talking about is like wrapping a present. Okay, so how much paper does it take to go around this whole thing? Or like painting it. Okay, so how much paint would it take to cover the entire surface of the figure? So surface area is something that happens on the outside of the figure. We're also going to talk about volume then, and volume is how much space is there inside of this figure. So if I was going to fill it up with water or rice or sand or something, how much of that would I need to fill up this figure? Today, in our first lesson, we're just going to look at section 1, and in section 1 we're going to be talking about what are called prisms. Prisms are figures where we have a base that is some shape with straight lines, okay, so not a circle, but some shape with straight lines, and then we're going to have that same exact shape on the top as we do on the bottom, so it's going to stand perfectly straight up. So we could have the bottom be a square, and the top would be a square as well, and it stands straight up, and we get what's called a cube. Okay? We could have just a general rectangle as our bottom, rectangle on the top, it stands straight up, and we get what's called a rectangular box or rectangular prism. You think about like a shoebox when you're trying to visualize these problems. Okay? We could put, though, any shape onto the bottom as our base. So we could have a triangle as our base on the bottom, the exact same triangle on the top, and then it stands straight up. Okay? We could also do like a hexagon on the bottom, hexagon on the top, and then it stands straight up. So we could do any shape as long as it has straight line figures on the bottom. So not circles. We're not going to talk about circle type figures today. We will get there though. Okay? So for today, the formulas that are going to be important are the cube formulas here at the top, the rectangular box formulas there, and then down at the bottom, there's one that just says prism in general, and that's where we would have any general shape on the bottom, like a triangle or a trapezoid or something like that. Okay, those are going to be the three sections of formulas that are going to be important to us today. When it comes to the test on this chapter next Thursday, you will need to have your volume formulas memorized. You do not need to memorize the area formulas, but you do need to have the volume formulas memorized. Okay? So as you work through your assignment, work on kind of putting those ones into your memory. For today's lesson, our notes have problems that are from both section 1 and 2. We are only going to work on the section 1 problems today. Let me make this a little bit bigger and easier to see. Okay, so I had originally planned to kind of do lessons 1 and 2 together, and then after some more thought that they're probably each individually enough to do on their own. So we're only going to do the 12.1 problems today, and then in our next lesson we'll wrap up the rest of the examples and then do the second assignment. So for the first question, we're asked to find actually 3 things. We're asked to find lateral area, total area, and volume. We want to find 3 things of a rectangular prism. A rectangular prism is like a shoebox. Okay, its sides are rectangles. It has a length of 6, a width of 4, and a height of 2. The lateral area formula says 2 times length width plus length height. Nope, width height. working. All right, let's try this again. The lateral area formula says 2 length height plus width height. Okay. What lateral area is calculating is the areas of the rectangles around the sides of this. So not the bottom of it, not the top of it, but the rectangles around the sides. So the front, the back, the left, and the right. So the front of this figure, if I wanted to find the area of just the front of it, I would do 6 times 2. The length times the height would give me the front of this. Okay? If I wanted to find like the left or the right of it, I would do 4 times 2. The width times the height would give me that side of it. Now because the front and the back are exactly the same, and the left and the right are exactly the same, we have this 2 in front of the formula. Okay? You don't have to memorize this formula, but I never like just throwing the formula out and not knowing where it came from. So that's why this formula is what it is it's calculating the areas of the front and the back, and the left and the right. Okay? That's what lateral area does. Not the top and bottom, but front and back and left and right. So we can plug in our values then. Our length is 6, height of 2, width is 4, height of 2. Order of operations says we need to do our multiplications first inside of these parentheses. So I get 12 plus 8, which is then 20 times the 2 gives 40. Total area, there is not a formula for on your sheet. Total area is more of a concept than a formula, so you will need to then know how to do this when it comes to the test. What total area does is it takes our lateral area, all of the sides, and it adds to it the area of the bases, the top and the bottom. Okay? So total area is completely wrapping this thing up. So not just the sides, but also covering the top and the bottom. So to calculate the total area for this, I would take my lateral area, how much it took to go around the sides, and I want to add to that the areas of the top and the bottom. Well, the top and the bottom are exactly the same size, so I can do 2 of, and then how would I find the area of the top or bottom? The length and the width, because if I look at the bottom of this figure here, it's the 4 and the 6 that create the bottom of it. So I'm going to do 2 times 4 times 6. Okay, so total area takes the area of the sides, which was 40, adds to it the top and the bottom. Since the top and the bottom are exactly the same, we can have that 2 there, and then finding the area of the bottom would be 4 times 6, the width times the length. So we do our multiplications first, and then add them together, and we get 88. Then this question asks for volume. Volume formulas do need to be memorized. The volume of a rectangular prism is length times width times height. So that is 6 times 4 times 2, which is 48. And there were no units given in this problem, but let's say that each of our measurements was given in, say, centimeters. First, it's important that they're all given in the same unit. If you're given some units in centimeters and some units in meters, you need to make those the same thing, okay? And that does happen on one of your homework problems. So watch out for units. We have to only work with like units. So if they are not alike, we need to make them be alike. So let's say that all of our length, width, and height were measured in centimeters here then. What kind of a unit would we have on our lateral area?
Centimeters squared.
Centimeters squared. It's still an area. So in the last chapter we talked about how area is square units because it comes from multiplying 2 of the dimensions together, a length and a width or a length and a height. Right? So area is still a squared unit. So then total area would also be a squared unit. Volume is a cubed unit because it comes from multiplying 6 centimeters, 4 centimeters, and 2 centimeters. So I got centimeters, centimeters, centimeters. 3 of them make centimeters cubed. Okay, volume is a cubic unit. Area is a squared unit. Okay? Questions on that problem? All right, for the next one, we're asked to find lateral, total, and length of a rectangular prism where we know a width of 8 and a height of 5, but we don't know the length. We do know the volume is 360. So since we know information about volume, that's where we're going to start the problem. Volume is length times width times height. So 360 is length times 8 times 5, which would be 360 is equal to 40 times the length. So we could divide both sides by 40 and find that our length is 9. Lateral area is 2 length height plus width height, and you don't need to memorize that formula. So that is 2, 9 times 5, plus 8 times 5. Order of operations, we need to take care of the multiplications inside there first, and then add them together, and then we can multiply by the 2. And make sure you do everything outside those parentheses first before you multiply by that 2. Total area is the lateral area plus the top and the bottom. Okay, lateral covers the sides. Total, we want to bring in the top and the bottom. Top and the bottom are the same, so we're going to do 2 times. And then to find the area of the bottom of this thing, its sides are 9 and 8. Okay, if we outline just the bottom of the figure, it's a rectangle with sides 9 and 8. So again, you do all your multiplications first, and then add it together with that 170, and we get 314. Okay, if there were units on this problem, the areas are squared units, and the other answer that we needed, the length, is just a plain unit. So just plain centimeters, plain inches, because we could measure that length with a ruler. Questions on that problem? Yeah.
For the LA, why can't you just distribute the 2?
You could.
Okay.
More work. I do that when I have variables in the problem, then I would want to do that, but when I actually know all the numbers, then I just work out the numbers.
All right.
But it would work to distribute. All right, the next one wants us to find a total area and a volume of a cube with a side of 4. Now, a cube is a special case of a rectangular prism because the length, width, and height are all the same. Okay? So we can still think about the same formulas working for it, but they actually simplify down a lot since our length, width, and height are all the same. So the total area, your formula sheet says surface area. Surface area is the same thing as total. Okay? Total means it covers up everything. Surface is the entire surface of the figure. So those two words mean the same thing. And it tells us that that is 6 times s squared, where s is the side of this figure. Okay? The reason why this works is if I wanted to find the area of one of these sides, they're all squares, so I would do the side times the side. Okay? Then, how many sides are there on a cube? 6. It's like a die, right? You roll a die and it's got 1 through 6 on it. There are 6 sides on a cube. So we've got one of those, what we call faces, is a square. So its area would be side squared, and then there are 6 of those faces. Okay? So for this one, we're going to do 6 times 4 squared. Order of operations, you have to make sure you do your squaring first. Don't multiply and make it 24. Do your squaring first. And then 6 times 16 is 96.
Why is this 6 and squared?
Each square, front, back, left, right, top, bottom, they're all squares. A square we learned in the last chapter is side squared. That's squared. There are 6 faces on a cube. Just like on a die, goes 1 through 6. Volume, we could think of as being length times width times height, and that's fine, but since they're all the same, we could also just say that it's side cubed, which, by the way, is why we call that third power cubed, is because it works for a cube. Okay, that's why we call a second power a square. We say side squared because that's what we do in a square. We call a third power a cube because that's what we do in a cube. And that's why we don't have a special name for like x to the 4th. We just say to the 4th because we don't have anything with 4 dimensions in our world. And we will talk about that more in a couple of units from now when we read a book called Flatland that we're going to talk about dimensions. So that's why we call them squares and cubes, because they work in squares and cubes. Okay. So for this one, 4 to the 3rd power is 64. The next question says, find the side length and total area of a cube again with a volume of 64. Well, in the last problem, it had a volume of 64, so we're just going to end up redoing that same exact problem over again, and that doesn't seem productive. So we're going to go ahead and change this to be 216 instead. So we'll get some new answers to this question.
The volume is 216.
We're going to change the volume to be 216. So then we are asked to find the side length and total area. Okay.
Their pictures like short. You don't draw for your problems.
You don't have to. I'm a very visual person. So for me, it helps to see things. But if it doesn't help you to see it, you don't have to draw it. So since I'm given a volume of 216, that's what I'm going to start with. And volume is side cubed. Now we've talked about how to undo a square by taking a square root. Okay? We can undo a cube by taking what's called a cube root. I don't expect you to know perfect cubes. So what we're going to do here is just kind of guess and check it. And we grab a calculator. Cube means times itself 3 times. So we're going to say if I do 4 times 4 times 4, is that 216? No, it's 64. Okay, so it's got to be bigger. If I do 5 times 5 times 5, is that good enough? Nope, that's 125. That's not good enough. If I do 6 times 6 times 6, is that good enough? And it turns out that 6 times 6 times 6 is 216. Okay? So we're going to guess and check our way to figure out what number do I multiply 3 times to get that value. Okay? When you take Algebra 2, you'll learn a lot more about cube roots and some techniques there. But for our purposes, we're just going to guess and check it, and they'll turn out to be nice numbers for you.
Is there a button on the calculator?
There is. It's kind of hidden in a menu, but there is a button on the calculator.
Divide that by 3.
No. Dividing by 3 is not the same thing, because that would be 3 times the number. We want the number 3 times. So total area, our formula is 6 sides, and each side is s squared. And in this one, we found our side is 6. And work that out, and we get 216. This is one very special case where the total area is the same as volume. That is only true for this particular case, where the side is 6. It's not true in any other case. As we could see in the last problem, we got 64 and 96, 2 different answers. Okay, so it's a very special case here that they turned out to be the same answer. One more example for today's part of the lesson. We want to find the same three things we've been working on: lateral area, total area, and volume. But this time our prism has a base of an isosceles triangle. Then it's not just a triangle, it's a solid. So what we're going to do is take this on back. Made that top one a little too long. And I can't teach that class. I'm pretty bad at drawing and art. The idea here is that we're looking at the base. You always want to be able to see what your base is. So like this one has a base of a triangle. So we're looking at that triangle, and then it's extending on back to create kind of like a long tent type thing here. Okay, so we're looking at the triangle, that's the base, and it's extending straight on back, and there would be another triangle in the back of this thing. Okay. We are told in this that the sides are 5, 5, and 8, and the height is 10, and that's the height of the prism. That's how far it is between the bottom triangle and the top triangle, or for the way I drew it, the front triangle and the back triangle. Okay? That's not the height of the triangle, that's the height between the triangles.
Are the bottom and top the same?
The bottom and top are exactly the same. Yeah, for a prism, they have to be exactly the same. Alright, so on your formula sheet at the bottom, there is a formula that just says prism, and there's not a picture, because any shape could be the bottom, and this would still be true. So it'd work for a triangle on the bottom, it'd work for a trapezoid, it'd work for a hexagon, it'd work for any figure being there on the bottom. So that's why they didn't put a picture on that. The formula for lateral area says per of base times height. What do you think per of base means? Perimeter. Okay? The per of the base is the perimeter of the base. So perimeter, we learned in the last chapter, means add up around all the edges. So the perimeter of this triangle is 18. And the height of the figure is 10. So our lateral area is 180. Total area, I said before, is the lateral plus the bases. Okay? There are two bases in this, and they are triangles. The area of a triangle is 1/2 base times height. So you can't forget those formulas that you learned in chapter 11 because we still need them. So we still need those area formulas here. So the total area is the lateral area plus the bases, which are the triangles. So there's two of them, and a triangle is 1/2 base times height. So the 2 and the 1/2 cancel each other out. What is the base of the triangle? 8. What is the height of the triangle?
We don't know.
Of the triangle? We
We
don't know, right? The height of the prism is 10. The height of the triangle, we don't know.
Pythagorean theory.
So we did problems like this in the last chapter where we need to find it. It breaks that 8 up to a 4 and a 4, and we get this nice triangle that we've worked with quite a few times. So you might just be able to know that that's going to be 3. If not, you can solve it with the Pythagorean theorem, but 3, 4, 5 comes up a lot for us because those numbers are nice to work with. 5, 12, 13 is another one that comes up a lot for us because those numbers are nice to work with. So if you learn to recognize those, it can save you the time of the Pythagorean theorem. Otherwise, you can always just go to the Pythagorean theorem on it. But our height here is 3.
Where did you get the 8 from?
That's the base of the triangle. The bottom of the triangle is 8. So then, sorry, go ahead.
I have a curiosity. How do you know which one is the base? Because couldn't it be either?
It could, if I drew it another way, it'd be a whole lot harder to find our height though. So since it's isosceles, I want to use the different one as our base.
But it doesn't actually have any classification.
No. Nope, you could rotate it around on any side. It's just easier in an isosceles if you make the different one be your base. So we add that up and we get 204.
If you made a different one to your base, what would happen?
It's a lot harder to calculate what your height is. You need trig.
I don't know.
So we don't want to do that. Last part of this problem, boys. Volume. This formula does need to be memorized. Your volume formulas need to be memorized. The volume of a prism is the area of the base times the height of the prism. So since our base is a triangle, that's 1/2 base times height of the triangle, and then we're going to multiply that by the height of the prism. So 1/2, the base of the triangle is 8, the height of the triangle is 3, and the height of the prism is 10.
Wow.
You multiply that all together, and we get 120. That's the height of the prism. That's the distance between those two triangles.
It's like standing up.
It's like standing up. Yeah.
Which one, which the capital H stands for?
The capital H is the height of the prism, the distance between the two triangles. The little h is the height of the triangle.
Looking at the base.
We're looking at the base. Yep. Okay. All right, so that is the end of the 12.1 portion of the problem. So your assignment is the 12.1 portion of the assignment at the bottom. And in our next lesson, we'll talk about the 12.2 portion.